I'm the close collaborator of our system security group at IU. He's the associate professor at the computer science department at Ohio State University. And his research interest are system and software security. He had a special focus on using programming analysis for a lot of security problems in the application layer and the operating system. And he has published over 70 papers in major security conferences such as IEEE Security and Privacy, the Oakland, and CCS, Using Security India, those are renowned security conferences. And he has served on the program committee of lots of security conferences. And he is a recipient of the NSF Career Award and AFOSR Young Investigator Award. So let's welcome Dr. Lee.
Thanks, Louis, for the introduction. All right, so today I would like to talk about how to uncover server-side vulnerabilities by using automated program mobile app analysis. This is joint work with my students and also my collaborators. Okay, so we know today mobile apps have significantly changed our daily lives. I'm sure every day when you get up, you must use mobile app to check the weather, right? And look at the traffic if you want to go to school, and online shopping, so on and so forth. So mobile apps really have significantly changed our daily lives. Okay. All right. So in my group, there are a lot of people looking at those mobile app security, the security in the mobile systems. So we understand for mobile apps, if mobile apps have to be really useful, it must collect the internet, right, to access data there. So this is typically how the ecosystem look like. You have apps in your phone, and then the apps will talk to the cloud to save some data in the cloud, and also pull data from the cloud. Look at the Google Maps, right? You use Google Maps, your phone cannot store the entire maps of your phone. So it must talk to the cloud. A lot of people have been looking at the security of the phone, so from our group, we look at. We actually started to look at this mobile security problem a little bit late. Our first paper was published in 2014. Early papers, in the mobile space since 2008. A lot of research group have been working on that. So for us, we know, okay, we're kind of late to join the game, and so instead, let's say we can focus on the security of the backend. So that's our today's topic about. So we want to analyze the security vulnerabilities in the backend. Mobile apps are our front end. Right, so this is usually show you how this backend, typically the systems in the backend. So our focal point is on the server-side vulnerabilities. A lot of people, as I said, analyze the phone, look at what kind of attacks attacker could do with your phone, and what kind of malicious app on the phone. For us, we say, hey, let's look at something differently. So we would like to analyze how the apps talk to the cloud and what kind of security problems with those backend. And as security researchers, certainly we are interested in finding vulnerabilities, right, before attackers. But this is very challenging because you don't have any code. You don't have their source code, binary code. No, everything's black box. So how can you analyze, how can you find vulnerabilities in the backend without access any code? So the key idea here is, all right, since we don't have the code in the backend, but what we have is the apps, right? We have the mobile apps, and we have other app code, we can do reverse engineering of all the apps. And then, so from the mobile apps, let's analyze how apps communicate with cloud and the protocols, reverse engineering the protocols. From there, we can discover the vulnerabilities. So that's all the high-level ideas. We're kind of lucky. In the past 3 or 4 years, we have published a number of papers in this direction. Our earlier work is on those authentication problems in authentications in the servers. That's our first paper. And later, we looked at the authorizations in the back end. And recently, we look at the data leakages in the back end. In today's talk, I will mostly focus on the data leakage vulnerabilities in the cloud. Okay, so we have heard a lot of news about the data leakage. This was actually in 2017, 2 years ago. We saw this news. It says Verizon data of 6 million users leaked online. We get shocked. So, hey, how come, right? When people using cloud, it sounds like cloud providers should protect my data. Why we are using cloud, but our data gets lost? What's the reason for that, right? We're very interested in that. And not just Verizon, Pentagon, right, also has data get exposed in the Amazon server. So because this news headline motivated us to look into why is that. And this problem didn't get stopped. In last year, 2018, you still see a lot of data breaches in the cloud. So then if you really look at the system, the ecosystem, this is how it looks like. So today, in addition to this, Amazon AWS, there are other type of cloud. Here is one of them. This is called Mobile Backend as a Service Cloud. It's called MBaaS Cloud, okay? This is how the MBaaS Cloud looks like. For mobile app developers, you write your code. You write your code by using the SDK provided by the cloud providers. So these guys like Amazon, Google, or Microsoft, they all provide SDK for mobile app developers. Then as developers, I just use Amazon SDK to develop my mobile apps. Then my apps, can directly talk to the backend. Then, developers doesn't have to worry about how to set up database, how to manage them. You just use their SDK, use their API. So here it shows the cloud has all those app engines, and also provide database services for the apps. Okay, and today there are a lot of MBaaS cloud providers. Here just list a number of them, but many mobile app developers, they adopt this. Okay, and as I said, we are interested in this data leakage problem. We are interested in why my data stored in the cloud get leaked, right? Why is that? So fundamentally, this problem is actually the access control problem. So you store your data in the cloud, and bad guys can access the data. Why is that? Because you didn't manage your data properly, right? So fundamentally, it is an access control problem. So what is access control? Access control basically regulates who can access what, right? So here, there's the Alice and Bob. Bob should access only Bob's data, not Alice's data, right? This is access control. To design and implement access control typically involves authentication and authorization. Authentication is about authenticating the user, right? Based on user's credentials, like user and passwords. Then the system knows it's you. And after that, it uses authorization. Like, hey, it will give you tokens and use tokens to, like cookies or tokens to allow you to further access data. So basically, you have authentication component and authorization component. Then you say, hey, my data gets leaked. It must be one of those two reasons. The authentication is poor or the authorization didn't configure properly. So then let's look at in the MBaaS clouds, right, how this authentication and authorization looks like. Here I show you, let's assume there's one app installed in user's phone. And then this app, well, first, the user has to provide, let's just use Alice, okay? User Alice has to provide her credentials, right, to log in the app. And meanwhile, you can see there is also another credential there called app key. Okay, so this app key is used to tell cloud provider this is this app instead of other app. Otherwise, cloud provider doesn't know who you're talking to. Okay, so there's an app key there, all right? And then it goes through this authentication, first authentication, then authorization, right? And then eventually, user Alice can access her data in the backend. Then if another user, Bob, right? Bob is coming in, Bob also enters his credential. In addition to this app key there, right? This two data has to be sent to the cloud. So, all right. This is like two different users, but these two users, they use the same app. That's why the app key is the same. Then that means I can just go to Google Play to download all the mobile apps. I can look at all those app key because it must be in the app. However, in addition to this normal user, right? There's a regular user, typical user. You enter your user and password. There's another user called developer, okay? Because they rent the cloud. They also have to log in the cloud to manage their data. So these developers or administrators, right? They will use another credential that is called root key. Okay, you see there's root key there, and you provide root key, then cloud provider authenticate you, and you can access your data. All right. So this is a big picture, all right? You have app key, you have root key. Now we're saying, hey, my data gets leaked. What are those reasons, right? Can anybody guess? What are the reasons? Here, developer somehow made mistakes here. Okay, they put root key in the app instead of app key. If you put root key in the app, I just reverse engineer in the app, I get the root key. I get your entire database. Okay. All right, that's authentication, right? So basically, this is our findings. So in the beginning of my talk, I mentioned we are very interested in why, right? So here's the why. We look at these three clouds, Amazon AWS, Google Firebase, and Microsoft Azure. This is what we found. The first root cause is the misuse of the keys, okay? Because you introduce many keys there, and developers get confused. Functionality-wise, of course, both app key and root key can be used to access backend data. Fine, right? Developers pass all the tests. They think it's fine. But if you put the root keys in the app, then because everybody can reverse engineer your app, they can figure out the root key. So what we discover is for Microsoft and Amazon, they have this misuse. The developer misused the keys, okay? The second root cause is the misconfiguration of user permission. So this happened in the Google and Amazon backends. Okay, so these are our findings. I will go through details, okay? So first of all, this one, right? The misuse of various keys in authentication. As I said, the root key, if developer somehow mistakenly put root key in the app, the entire backend gets compromised. So let me give you some examples. These are the real case of the root key misuse in Microsoft Azure. Okay. Basically, the first one, the Azure storage, you can see the first line, the first look shows as our account key. That's a root key. Second one is SAS. That's the typical key. So we found the account key actually is in the app. The second one is notification hub. That's also from Microsoft Azure. So the last row is the full access key. So there are only slight difference. You see, this is a listening key. This is the full, access key there. If developers just somehow put this full access key in your in the app, they, like I said, right? This is not secure. So that is the misuse of the keys. The second one is the misconfiguration. Okay, so why people could make mistake in the misconfiguration? Okay, the reason is actually because those configurations is too complicated. So for Google's Firebase backend, you give developer a language, a programming language to write your configuration. You think that sounds very complicated, okay? Then of course you can imagine there will be bugs, there will be vulnerabilities. So here are some examples of those configuration in Google Firebase. Google Firebase is our real-time database. So this is the one shown here is the correct configuration. Basically, it says when the user wants to access a particular resource, the user ID should match. Okay, the user ID should really match with the one they specified there. When you read or write, right? When you read the data or when you push data there. For incorrect configuration, okay, somehow, let's see. Maybe that's video screening, some problem. Okay, so this one basically says, all right, everybody can read and write data. It's true. Everyone can read and write data. If you configure this way, your database gets leaked, okay? The other one, that's also very interesting. It says anybody, as long as it is authenticated, you authenticate it, you can access anything. All right, that's very interesting, right? So they didn't check like you should really access your data. Instead of, oh, authenticated, you can read it, okay? So to give you some ideas on this one, right? So actually we did a very earlier study on this, okay? On how to identify the configuration of this one. Like they just configure user can access data, right? As long as user gets authenticated. So let me talk about this one, okay? The how we can automatically identify that case. Like, hey, they just configure user gets authenticated, they can access. So here question is, how can we automatically identify those guys? So basically it's the authorization problem, right? The authorization, they configure authentication. Yes, they do have authentication, but the authorization is useless, okay? So if you look at authorization, we talk about, okay, when you do authorization, typically server have to give user some tokens, right? Or cookies. Use that cookies to access your data. If there's no token, that means, okay, just authenticated, then that's it. Of course, that's insecure, right? Or when you use the access resource, they give you a very, random your resource ID. I think one example is this one. For students, when you write papers, right? When you use overleaf, okay, I'm going to use this URL because I know attackers cannot load this. Attacker doesn't know that's random resource ID, right? It's secure. This is definitely secure, okay? Or the problem is developers actually does give user a token, okay? But that is just a token, not the token. The token should be very user specific, okay? So we are very interested in this. When we analyze mobile app, we really found those tokens there. It's not like they don't provide any token. They all know they have to provide tokens, but they just have, it's just a token, but they don't enforce, okay? So here, like I said, right, we are interested in how to uncover this automatically. Let me give you an example. Okay, so this is a real example. We discovered this, I think, in 2017, 2 years ago. This app, after user login, here we focus on the authorization. Okay, typically it happens after authentication. After user login, the server will push data to the user, right? So server will push you some data. So here is the one. So you can see after user login, user have to, this is a HTTP request, okay? It's HTTPS, but you can use our proxy to trace those HTTPS. So here you observe that, okay, right, this is like gets resource, right? You can see get something at this this 21690. Maybe you can guess. Maybe that's a user ID or something. Okay, this doesn't matter. Just guess. Maybe the resource ID. And then there is also our in-app token. This is a very long hex string, right? That sounds like a very random number there. And this one, when Alice log in, Alice sends this request to the server. Okay, you can see there are token there, the user ID there, sounds like secure. And then they got the response from the server. This is the response message. They also send you some like, oh, user ID, this one, and object ID is something else, okay? This is after user Alice login. Then to do security, you know, how can we identify this automatically, right? We rely on some techniques. So here we rely on a differential analysis. So what about let me also register, this is Alice. What about let me also register user Bob? Let's ask Bob to access as well. So this is what you see in the traffic. So Bob now it becomes different. This is 21691. Okay. Previously it's 21690, right? So 21691 and then followed by a token. This is token is FB1F15, right? Something like that. Token, of course, previous one is different, right? Previous one is E67, something like that. Okay, you see, oh, there are user ID, some token there, right? And you observe, okay, here's the response message. They're different, right? This is a two legitimate request and response. And we are interested, does server really enforce token? How we do that test, right? We will do this automatically. So what we did is, all right, let's switch, okay? Since we control the clients, we control apps, okay? So then let's switch user ID. Maybe I don't know which one is user. I don't care. I do the diffing. I do data analytics, basically align two messages, look at which one is different. Let's switch. So I just switch from 21690 to 21691. Basically, I use Bob as a user ID, but I use Alice token. I use Alice token, Bob as ID. Then I get Bob's data. All right, what does it mean? That means server didn't check the token. They just use user ID. Oh, user gets authenticated. It's user Bob. Okay. So yes, this is what we discovered. And then how to do this automatically, right? Let's do an automatic system to study this. So we developed a tool we call Scope. This one can basically analyze the authorization problem and take mobile apps as the inputs and communicate with cloud. And we have something, the man-in-the-middle proxy there to look at the traffic and then to do those substitution and manipulation. It's a fuzzing, basically. You can understand in that way. And we do differential analysis. If you give me just a single user, I cannot tell this. But if you give me two users, I can do this. So you can see here, you have Alice and Bob, we basically control this request. And then we let this tool, the system automatically, communicate with cloud, and then we find vulnerabilities. Of course, you can imagine if you want to do this study in large scale, how can you get user accounts, right? So in this study, we actually analyzed 5,000 mobile apps. So I cannot register a user for 5,000 apps one by one. That's very tedious. So what we did here is we use the single sign-on to log in the app. Okay, I'm sure you heard single sign-on, right? Basically, you don't have to register an account with all the services one by one. You just register a Facebook account. Then if the service allow you to do single sign-on, yeah, you automatically can log in 5,000 services. So this is what we did. We basically use single sign-on to generate post-authentication message. Then we control Alice and use Alice and Bob. Then we do the fuzzing. Then we identify vulnerabilities. So we did this study, in 2017. We basically crawled those top 10% apps. And we use Facebook login, like I said, right? And that's why we focus on the apps that use Facebook library. And eventually we have about 5,000 apps use Facebook login. This is dynamic analysis. So we cannot statically analyze app, tell you the vulnerabilities. We must run the apps, get the traffic. we have like 6 phones run there. You know, the students took about a week to run all these 5,000 apps. And this is what we discovered. We run about 5,000 apps, takes about, you know, 500 hours for a week, you can imagine. And then, interestingly, we found, you know, we found actually some HTTP message. So in the traffic, we see HTTP traffic. You can imagine it must be HTTPS, right? But there are some HTTP traffic there. Maybe it's like 5% or something there. And then, okay, how many vulnerable apps we found, right? That's maybe the one you're interested. That is HTTP traffic. In total, it's about 300 apps out of 5,000. They don't enforce the token. They don't check tokens, basically. Just a token, that's it, I don't care. It's Alice or Bob's token, but they should have checked that, right? Then if you trace back, what's the root cause for that? I told you, it's the root cause of perhaps this one. Then configure it, authenticate it, no, that's it. This is why, right? Why you found the case there. They just configure, authenticate, not now, then it's this problem. Even though the backend has everything, backend has token generation, they have everything, but they don't enforce. Okay, to give some ideas on what kind of problem, you know, what kind of leakage is this, right? So here's one app. So we basically anonymize the app name. We call app K. This app K, this is what app K will return to user. If you enumerate, you can just brute force the entire user's, you know, profile. So here, what you observe is, right, this is the backend actually give people's password back. Why is that? It's impossible. Why server, when I log in, server give me my password? Even though that's hash, right? It's a hash. But you can easily crack the hash. Actually, this one is, of course, for this study, we didn't break other accounts, okay? We register Alex and Bob. We only look at Alex and Bob's return value, okay? So for this one, actually, you can easily crack it by using like a lot of tools, online tools to crack people's passwords. So that means if I'm really evil, I can just go ahead and dump the entire database to, you know, pull it and even, you know, crack people's passwords. So, right, of course, email address, this maybe, you know, this can be leaked, and even user's address can be leaked. So this is actually, when you log in, this is, you know, server give you this response to the user. Okay, I just show you, right? You can actually develop our automatic program analysis system to identify those vulnerabilities. That is for authorization. So here again, right? I told you you know, my group, we basically are very interested in using program analysis to solve problems. So here after I show you that auth scope, so here let's come back to this MBAS cloud. So here we are interested in how to do this in a larger scale, right? We know there are like 3 million apps in the Google Play and you know, also in iOS and Apple markets, right? A lot of apps there, and how can you know, identify those vulnerable backends? So here I list a number of challenges there. Like if you want to do this in a automated way at large scale. For instance, how to systematically identify the misused keys, okay? Actually, this can be done because imagine the cloud provider must give developer those APIs, right? Developer has to use those APIs to communicate with cloud. The API must take parameters like root key or user key, whatever, right? So you can actually, from the APIs, you can know, you can know, you know, is there a root key in the app? So that's first problem. By doing cloud API analysis, you're able to tell a root key and the user key. And then the second challenge there is how to identify the value of the keys. Even though you notice there are a root key or app key, right? You have to identify. You have to get the value. Otherwise, you don't know, you can use that to do the attack. So you have to do string analysis, basically. And we also noticed the apps have been obfuscated. According to our statistics, 20% of the apps are obfuscated. So you have to design an obfuscation resilient approach to analyze those apps. And finally, even though you find all those, potential vulnerable case, how do you confirm that? Definitely, we cannot grab their database ethics, right? Otherwise, we are doing the attacks. So how can we identify the data leakage without really leaking users' data? So this is another challenge. So fortunately, we have some techniques to address these problems. So I can go through them one by one. This is actually the work we call Nick scope. The source code is open. If you're interested, you can play. The Nick scope has 3 components to solve the challenges I just mentioned. The first one is to identify the APIs, the cloud APIs used by the mobile apps. Okay, we want to identify those APIs. The input, it takes 2 inputs. One is the APKs, right? You download from the app store. Second one is the SDK APIs, because we have to know which API takes app key or root key as parameters. We have to know this knowledge. Okay, so those are the inputs, and the tool is going to automatically identify them. So here are those APIs we are interested. So not that many. So you can see for Amazon AWS or Microsoft Azure or Firebase, those are APIs. We know which parameters take the account key or root key. And so the first part, the only challenge there is to deal with obfuscation. So we have some techniques. Okay, if you're interested, you can read the papers. All right, the second one, string manual analysis. Why we have to do this? Because the string they could do some computation, like string concatenation or some kind of data arithmetic. You cannot directly grip the string. Okay, so you have to do some analysis there. To give some ideas there, you can see this is a real example. Here we are interested in the value of at line 23. So, all right, where is that? So here we are interested in the value, right? So basically, the technique is you do backward program slicing. You just identify the statements that are relevant to the generation of the value, and then you replay the execution. Then you can get the concrete value. So that's a high-level idea there. Finally, there's vulnerability identification. How we do this? We actually use a side channel approach. We don't directly grab the database and look at the records. Instead, we use side channel. We look at all the API, because the API will tell you the response. So if the response, right, is like unauthorized operation error, if that's a response, then you know they did it correctly. They did it incorrectly, right? There's no vulnerability. If you say let's access data, let's access non-existent data. If they say, oh, the data does not exist, that means it allows me to access that one. That means it's vulnerable. So this is how we use that side channel to infer there is indeed a vulnerability. Okay. So all these analysis done. Basically, we analyze the APIs, the request response to understand that. Definitely, of course, it's called specific. Okay. Then we build a tool, right? The tool we basically analyze about 1.8 million apps in the Google Play Store, but we focus on the 3 clouds, okay? Amazon, Microsoft, and Google. So for these 3 clouds, about 100,000 apps use these clouds, okay? Use these 3. Of course, there are some other cloud providers as well. And here is only for app Google Play Store. So you can notice that there are like 20%, right? 20% gets obfuscated. And interestingly, you can. This also shows some statistics. Like there are some apps use just only Amazon, or just use only like Azure or Firebase. This is like, but some of them actually use 3 services together. We haven't looked into why they use 3 services together. Maybe a split database into 3 clouds. Okay, but something maybe interesting to look at. Okay. Anyway, so basically this is a distribution of testing apps, and here is like how we identify the cloud APIs, right? So we have those API inputs, and we are interested in those strings. So this is some statistics. Okay, maybe we can skip this. All right, the most important one, right? What we found. Here is the distribution of here are the statistics of the detected vulnerabilities. And for all the three clouds, you know, they're all vulnerable. And the yellow, the one highlighted in yellow is this is the misuse of keys. The green is our misconfiguration in the authorization. So in the misuse of the keys, they happen in the, you see, as you have, you know, have two cases of those misuse. You know, why is that, right? So what we discover is the documentation is wrong. The Microsoft documentation, they put root key as an example there, and then developer followed that example. Of course, when we report this, they immediately remove that. They just, you know, direct update their documentation. Anyway, so you can see, right, Azure has here basically show you for both Office Kit and Office Kit, we can all detect, okay? So you can see about, we found like 85 apps. Is there account key misuse? Right, so basically, yes, and AWS has this root key misuse. Even, I'm sure maybe you heard news about open S3 storage. The S3 storage is open, entirely open. There's no authorization. So this is what we discover. Yeah, open database, no permission checks. Okay. Here, maybe give some ideas on, are they seriously, right? Are those apps? Here, give some statistics. So, of course, our study, you know, this one is a very systematic study. We analyzed 1.8 million, right? And among 1.8 million, we found 100,000 that use all these APIs, all these clouds. And you can see, of course, this is non-vulnerable, right? There's some not vulnerable. This is like how many users use them. The vulnerable ones start with like 100 million to 500 million users. Very popular apps, right? 100 million. And we found here is the statistics. We found 1 in AWS, 9 in Google Firebase. So, okay, this gives you basically a bad guy. If you want to get data, they can get a lot of data. Okay. So very popular apps, actually vulnerable. And also, if you want to, Google Firebase, a lot of, you know, many vulnerable apps there, right? The reason is in our data set, yes, we indeed find many Google's Firebase backends. The most problem come from the authorization, misconfiguration of authorization. So of course, we also communicate with Google, right? Tell me why is that? So part of the reason we have to blend because that was very sophisticated configuration. So they have to simplify that. Anyway, so here is like, hey, let's, like I said, right? We are white hat. Okay, we have ethics. We don't do attacks. So we have to responsibly disclose all these vulnerabilities we found. So we first communicate with all the cloud providers. We cannot just contact each individual developers because there are like tens of, 15,000. We cannot contact them. But we contact cloud provider. Cloud provider contact all these app developers, and then the cloud providers, they have also done something. So I just mentioned, right, the Microsoft immediately corrected wrong documentation because they put root key in there. The example is use root key. Okay. Google, right? Google, when we talk to them, they say they will provide more user-friendly SDKs, and also they will do more tests with the backends to make sure user wouldn't misconfigure their permissions. And interesting for Amazon, before, actually 2 weeks early before we disclose them, they actually add 2 features there and do permission checks with the S3 storage. So we cannot claim it's our contribution because they already noticed that problem. So we first did a study, and it's when we want to disclose to them, but they already add some checks there, okay? So here's the example of that. Microsoft's documentation. You can see the updated in December 27. This actually we disclosed their the vulnerabilities. So they add some disclaimer there. So you can see it's your account link and account key, right? Which key for? So basically, you can see here they just say that only use share key authentication for testing progress. Your account link, blah blah blah. Okay, so they basically just mention the case we discovered. Okay, so for Google, right? We actually communicated with Google last month. We say, hey, how's it going, right? Did you guys fix the problem? This is what Google told us. So they said, how the big addition in their side is they do some like more testing. You can see, right? They do some local emulation and tests against their products, okay? And also they alert customers, you know, for anyone using their database with open rules. That open rule, they have a tool to detect that. And then they are exploring more options. So this is the Google's response. Okay. And of course, we're not the first to do those vulnerability discovery, right? A lot of people work on that. And this work, you can imagine, it is closely related to protocol reverse engineering, right? We basically look at the communication between the app and the cloud, reverse engineer, like which one is token, which one is user ID, and then things like that. So protocol reverse engineering, a lot of work there. And we also do dynamic analysis. In the first work, you know, we show you, we run 6 phones to generate traffic to look at whether server side will enforce people's token. And for the app vulnerability discovery, right? So many people focus on the client side vulnerability discovery. So these are the works actually in my group. We focus on discover vulnerabilities from the server side. And there also works on identify the misconfiguration, especially in the system community, because when you use software, like system software, you have to do a lot of configuration and run it, right? So there are a lot of tools there to check those misconfiguration. Okay, so what I talk about? Basically, I talk about, first talk about the tool that is able to use in differential analysis, automatically log in the server to identify whether the authorization has been properly configured. We tested about 5,000 apps and identified 300, right? If you remember, 300 of them, they are vulnerable to those authorization problem. And then I talk about another tool called leak scope. This tool is able to, this one is static analysis because we just want to analyze APIs. So we can do entirely static analysis. And this tool is able to analyze the data leakage vulnerabilities, and it performs call API identification, streamline analysis to identify vulnerabilities. And we tested about 100,000 apps use these 3 clouds, and 15,000 of these apps backends, they are vulnerable, okay? And here are 200 from Azure, and 1,600 from AWS. The rest are Firebase. So this is what we discovered. And you were wondering, what about future works, right? So there are a lot of problems in the backend. And here you can see we didn't access any source code or binary code of backends. All the study are done entirely in the front end, right? Or just mobile apps. Okay, either static analysis or dynamic analysis. There are lots of other vulnerabilities as well. What about SQL injection? If you wonder, hey, why mobile apps, the backends has any SQL injection there? I can tell you the answer is yes. We also found SQL injections in the backends and cross-subscription as well. So, and what about others, right? What about the backend, like VM, operating system, and the network stack, like SSL? Did they all use, properly? So actually, we just have a paper in upcoming using security. We did empirical analysis. So we analyzed, how those backends, their software stack, like virtual machines, libraries, and the apps, what kind of vulnerabilities still there. So if you're interested, please check out this paper. Okay, so that's all I want to talk about. Any questions? Thank you. Yeah. And by the way, the code is actually open. If you're interested, you can play our last tool. Thank you. All right. Yeah. Mm-hmm. Oh, okay. I see. Good to know. Yeah. Thank you for that. Yeah.
They added the information 2 weeks ago. So what do you think?
They didn't mention that to us. We just checked. We checked, hey, what they did, right? They added checks there. So for my students' basic communication, right, I didn't know, I asked all these details. So I think we didn't get, Amazon sounds like it's not as Google or Microsoft, that more, responsive to our, questions. Yeah. Okay. Yeah. Right. That's a great question. Actually, we do have those statistics. I think it's reported in the paper. So like what kind of leaks there and what kind of vulnerable apps are there. Yeah. Yeah, it's reported in the paper. For both, I think we have very concrete case studies. Yeah.
So do the name of the cloud service is called
MBAS.
So those servers, those are app servers, the backend server of those apps, they use it actually regular EC2, S3, or
That's a great question. So we didn't fingerprint that. I cannot tell you what kind of real software the software they're using. I think our secret paper talk about they use some Microsoft, VMware's virtual machines. We identify some VMware virtual machine instances with that. Right.
I think my question is, do those cloud providers provide anything specific for those mobile apps to use that?
Yes, they do have that. That's true. You could rent Amazon EC2 as a single virtual machine and you put your database there, right? That's one type of use case. Right. For mobile backends, they have their you don't rent EC2 anymore. You just pay me that API. Maybe they take care of all the backends. You just use API to communicate with the backend. With app key, all the requests has an app key there, and they manage that. Yeah. Okay, thank you.